everyone, welcome to another QandAHelp Explainer. Today, we are tackling a really crucial WAEC biology past question together. We're going to break this down step by step so that when exam day finally rolls around, you won't just be ready, you'll be totally confident. Let's get into it. Okay, let's dive right in. The question asks, the following measures are adequate for conserving crude oil, except. Now see that word except? It completely changes our mission here. We are not looking for a good conservation method. We're actually on the hunt for the one option that does not conserve oil. We need to find the odd one out.
But before we even look at the options, let's talk about what's really at stake here. Crude oil is a non-renewable resource, right? If you chase it back, 100 million years ago, organic matter was buried deep underground. 50 million years ago, immense heat and pressure finally turned it into oil. And today, well, we humans pull it out of the ground and burn through massive amounts of it almost instantly. It literally takes nature millions of years to make, and we just use it up in a flash.
Because it takes so incredibly long to form, we absolutely have to practice conservation. But what does that actually mean in a biology context? Well, conservation is basically just the careful use of a resource and the reduction of waste. Our main goal here is to stretch out our limited, existing supply of crude oil for as long as humanly possible.
Think of it kind of like a giant water tank that feeds your house. If you want the water inside that tank to last a really long time, what do? You reduce the flow of the tap. You use less. That is true conservation. But what if, instead of turning down the tap, you just go searching for a brand new water tank? Sure, finding another tank might give you more water for a little bit, but it doesn't actually slow down how fast you're draining the water you already have. Keep that analogy in your back pocket. It's going to come in handy.
So looking at option A, finding alternatives for petroleum products, it's pretty fascinating how perfectly this fits our goal. Think about grabbing a reusable cloth bag instead of a plastic one, or using alternative building materials. Step 1, we introduce those non-petroleum alternatives. Step 2, the global demand for petroleum drops because, well, people simply don't need as much of it. And step 3, because demand drops, crude oil is successfully left in the ground and conserved. So option A, fantastic conservation measure.
Moving on to option B, electric cars. We're building on that exact same logic here. On one side, you have traditional petrol cars that depend entirely on crude oil extraction just to run. On the other side, you have electric cars. By plugging a car into the grid instead of filling it up at a gas station, we directly cut down our daily consumption of petrol and diesel. Less petrol burned means less crude oil pumped out of the earth. Option B definitely conserves oil for sure.
Then there's option C, the use of ethanol-powered engines. Ethanol is honestly a brilliant substitute. Step 1, we harvest renewable plant biomass, like corn or sugarcane. Yeah, literally the same stuff in your cereal can fuel a car. Step 2, we process that into ethanol fuel. Step 3, we use that ethanol to power our engines instead of traditional petrol. By using biofuels, we're replacing a non-renewable resource with a renewable one, leaving more crude oil safely tucked away underground. So option C is another great conservation measure. But then we get to option D, exploiting new crude oil reserves. Let's contrast this with true conservation because exploiting means sending out heavy drill rigs, tearing into the earth, and extracting even more oil just to increase our supply. Remember our water tank analogy? This is literally just looking for a new tank. It does absolutely nothing to reduce our dependence or decrease our usage. Actually, drilling for more oil is the exact opposite of trying to use less of it.
So here's the crucial point. When we stack all these options up, A, B, and C all get a big green check mark. They all actively reduce demand and conserve oil. Option D, however, is our glaring red outsider. Exploiting new reserves does not conserve oil. And since our question asked for the measure that is adequate for conservation except for one, option D is undeniably our correct answer.
Real quick, before we move on, I want to give you a little exam shortcut, a way to mentally map these concepts so you never get tricked. Just remember, conservation always means reducing use, finding alternatives, and avoiding waste. On the flip side, exploitation means extracting more to use more. Whenever an exam throws an except question at you regarding conservation, don't panic. Just calmly look for the outsider that falls into that exploitation category. Okay, let's do a really quick recap to lock this in before we test it. 1, crude oil is highly non-renewable. 2, true conservation extends the life of our existing reserves simply by using less. 3, alternatives, electric cars, and ethanol are awesome because they directly drop petroleum demand. And 4, exploiting simply increases extraction, which is definitely not conservation. All right, let's put this to the test with a quick quiz. Which action best conserves fossil fuels? Is it A, increasing petrol vehicles, B, using public transportation, C, drilling more wells, or D, burning fuel unnecessarily? Think about what we just learned about reducing overall demand. If you lean towards B, using public transportation, you hit the nail on the head. Think about it. A bunch of individual cars driving to the exact same place creates a massive amount of fuel waste per person. But if you pack those same people onto one public bus, you have a very low fuel use per person. Public transport slashes overall demand, making it a perfect conservation action. Let's keep that momentum rolling. Quick quiz number 2. Which of the following is a non-renewable resource? A, sunlight, B, wind, C, crude oil, or D, forest trees? I want you to think all the way back to that timeline we looked at right at the beginning of our session. And this brilliantly illustrates the massive gap between nature's resources. Stuff like sunlight and wind, they renew instantly every single day. Even forest trees can be replanted and grown in a few decades. But crude oil, it takes millions of years to form under extreme heat and pressure. It is the literal definition of non-renewable. So C is the correct answer. All right, final challenge time. Quick quiz 3. Why does using an alternative fuel conserve crude oil? Does it A, create oil immediately, B, reduce petroleum dependence, C, consume more petrol, or D, increase drilling? Tie this back exactly to the core concept of alternative fuels, like the ethanol we discussed earlier. Boom, it's option B. Using alternative fuels reduces our dependence on petroleum fuel, which literally just means less crude oil is required to be pumped out of the earth. Lowering our daily dependence is the absolute golden rule of conservation. You guys crushed that. If you liked breaking this down and you really want to master all your upcoming exams with this exact level of clarity, you've got to head over to QandAHelp.com right now. The whole platform is built specifically to give you in-depth, step-by-step explanations for WAEC, NECO, and JAMB so that you can pass with flying colors. The link to review this specific question is below, and make sure you subscribe so you never miss a lesson. I want to leave you with one final, pretty powerful thought today. The choices we make today decide the resources we have tomorrow. This is profoundly true for conserving our planet's crude oil, but you know what? It is equally true for you right now. The choices you make today about how you study and prepare will absolutely decide the success you have in your exams tomorrow. But looking at the big picture, it leaves us with a pretty massive question to ponder. If crude oil takes 50 million years to form, what happens to our world on the exact day we finally pump that very last drop? Keep that curiosity alive, and I'll catch you in our next explainer.